We are Decibella Notte, and we are Garrett Horton, Nick Rollins, and Clarissa Westover. The objective of our process controls and dynamics project was to control the output of a song to a desired set point despite the variation in the song itself. We've all heard those annoying songs that change volume from second to second, or when the commercials turn on, they crank up the volume to try and get you to pay attention. It's very annoying, and our objective was to stop that. For our sensor, we used a microphone that hooked up to an Arduino, which was functioning as our controller, and our actuator was the computer controlling the Arduino. We empirically derived transfer functions, and we fit one to a linear fit and one to an exponential fit. And we also did a doublet test and then fit an FOPDT model to that doublet test. And these are the results of those tests. For a doublet test, we collected data points every 20 milliseconds and averaged them over to get a smoother curve to recreate the waveform and represent it as a mean noise level. And these are the initial parameters that we got in the top right. And we did make further improvements on them later, which we will report later in the slides. As you can see, the fit isn't great, but it's a good initial starting point. Using those parameters and an aggressive tuning, this is what our data looked like, our graph. And as you can see, it's not very good. It oscillates a lot. It saturates. It reaches 0 and 100 level. So it's not a very good model, and lots of room for improvement. And so we used the IMC tuning parameters. We tried aggressive and non-aggressive, and we also took large sample times to average the data. This on the left side is the aggressive tuning, and we also tried more conservative tuning, and that's on the right. As you can see, it really didn't dampen the oscillations at all. It's still very all over the place. For this series of data, we did a wider sampling, and so for every point that we plot, we have more sampled points in it. And so you can see that smooths out the oscillations, but it's still oscillating and still not a very good fit. So as far as results go, no matter what we did, it proved to be an unstable system, whether we used steady inputs or whether we use dynamic inputs. And what we mean by that is, we used tuning forks to provide a single steady sound as opposed to a song, which is always changing the sound level bit by bit. And even when we used the steady tuning forks, it still proved to be an unstable system, as you can see in this slide here. So this was with the tuning noise for 30 seconds. This slide shows 30 seconds with a song, which is the dynamic input. And again, it's mostly noise. It's very unstable. You can't really see a trend. These are the best tuning parameters that we were able to get. And in the end, we weren't satisfied enough with the model fit to be able to say we've achieved our objective, and so we are reporting that we are incapable of achieving the objective. And here's some reasons why we think that may be. We were unable to truly represent the waveform due to limitations in the sampling. Also, our process variable still had a lot of waveform character, and this meant that our volume was trying to follow that sine wave. So we think it is not our controller that was unstable, but it was following a poor representation of what we wanted to control. This is also evidenced by all the things that we did to try and improve our controller by trying different tuning parameters, more aggressive and more conservative tuning. We tried a handful of things and nothing seemed to be working. And so we don't think the problem is the controller, but we think it's the waveform character itself. And lastly, our transfer functions were empirically derived, and we had to estimate fits that broke down at the limits, both the upper and lower limits. And just for fun, this is a picture. These are some pictures of our little ones. My 5-month-old, Nick's two children, Daniel and Thomas Rollins, and Thomas is just 7 days old now. So um, he's a little bundle of joy, I'm sure. And of course, we can't forget Clarissa's little sheep, Valhalla Westover. Thank you.